This is a region where we have the electric field which is directed upward, as well as we have a magnetic field which is directed towards right from north to south. And kindly consider these two fields separate. I mean, they are not mixed into each other. So magnetic field is basically towards positive x-axis, whereas the electric field is on the positive y-axis. And if in this region where you have applied the both fields simultaneously, and you throw a one proton, that is just a one proton, let's say if you throw along the z-axis, I mean to say, so what will happen? It will go undeflected in this field. So if you throw alpha particle and electron with the same speed, what will be the path of these two? So you must understand one thing, that what happened so that the proton went undeflected. So basically, a proton has experienced both forces, electric force as well as magnetic force. So we must see this thing in the different scenarios. So in the first scenario, because we are talking about a proton that was going into the plane like this, positive z-axis, so this is the direction of its velocity, whereas the magnetic field is on the positive x-axis, and there is an angle 90 between them. That's why the proton will experience maximum force. And if you apply the Fleming right hand rule for the charges like this, so you see that my thumb, which is showing the velocity, is going into the plane, means away from me, whereas my this first finger is showing the magnetic field that is going towards the right. And what is the direction of this second finger? That is downward, which means that the proton have experienced the magnetic force downward when it was traveling from that region. And when the proton was traveling in this region where we have electric field, so it is a proton, so it will experience force, of course, in the direction of the field. So this is the electric force, whereas this proton, when it reach at this point, this is a direction of the magnetic force, which means basically what happened, the electric force balanced the magnetic force acting downward. And let's equate them. So maximum magnetic force is always qvb, because charge is entering at angle 90, whereas the electric force is electric field strength times charge. You can cancel the charge with charge, and the velocity is equals to E over B. It means that this velocity of this charge is independent of the charge magnitude. So no matter you throw the electron or alpha particle, it will not uh, it will not go or deviate in any other direction, because it depends directly proportional to the electric field strength and inversely proportional to the magnetic field strength. So option D is right answer. Electron and alpha particle both will not deflect, because velocity is independent of the magnitude of charge.